have had some problems with the SwiftUI navigation, and it does not seem to be fixed very easily, especially the inconsistency over the different versions, for the different iOS versions. So I have started to look for a better alternative, how to organize my projects in a more general way so that I can use easier UIKit and SwiftUI. I really like the way the navigation in SwiftUI works because it does a lot for you automatically, but I don't have a lot of control about the customization and the behavior. So you see here, this is the project that I developed and the navigation tutorial for SwiftUI. And I have here one simulator running for 15.4. So this is in a tab bar. So I'm in the first tab and I can click on this button. This is a navigation link. I go to the first detail. I can now select from this list. And I go to the second detail, and you already saw that this was jumping. I can programmatically dismiss this or pop back one level by pressing on this. This is happening when I press on the go one step back button. It's not animating nicely, it's just pushing back. Oh God, this is really annoying, this flashing. And the other thing that is very common to do with navigation views is that you go back to the very first screen, or that you want to pop back to the first screen in the navigation stack. I can programmatically do this with this go back to the root. So you see, we didn't even see the second step. So it's basically mostly working. This looks very different when I'm here on 14.2. I cannot, the project is using the new SwiftUI lifecycle, so I cannot run it for iOS 13, but it definitely does something else there. So I go to the first detail, and then the second detail, and now it's animating nicely. I can go one step back. It's animating nicely one step back. And then when I go back to the root, it goes nicely back to the root. Okay, but so after playing a little bit with this around, you saw now that sometimes on a random occasion, instead of from the last screen directly showing the first one, it goes first to the second and then to the first one. But I don't know why it does it sometimes and sometimes it's not. And I mean, it's doing it nicer than for iOS 15, but it's still not consistent, and I don't like inconsistent behavior. Also, in this case, it might not look like a lot, but maybe you have like 5 screens and then going back for all of them, maybe the users gets confused or something. So I really try to figure out how to make this work, but I just don't have a lot of access for SwiftUI's navigation stack. So I'm going to use a completely different approach. I'm not going to use SwiftUI navigation. I'm going back to UIKit navigation, to, for example, UINavigationViewController, UIViewController, and maybe even UIPageViewControllers. But then it's like, how do I start my project? Because I cannot use the SwiftUI lifecycle, and I definitely don't want to use storyboards because this is too much UIKit. So we need to do the navigation programmatically in UIKit and then find out how to put our SwiftUI things in or our UIKit. So it's actually a really nice way of doing it because you can maybe you already have an existing application with a lot of UIKit inside and you just aren't sure how to get SwiftUI in there. The good thing about this one is you can, by not letting SwiftUI do so much, you can take more control, and maybe in some cases it's probably better because if you don't know why something is updating or happening or pushing back, it's probably better to go one step back where you have more control with UIKit. Okay, this is the motivation for this and in this video, because the topic is, I can talk a lot about this, and building a nice project can take some time, especially because I want to also include some more interesting example, not just putting one view controller on the screen. I want to have different coordinators, different subflows, like you see here with 2 tab bars, maybe even an onboarding sequence or onboarding flow. So we have different subflows in the app. Also the question of, because I have now this one more coordinator, how do I pass data? How do I pass data between different view controllers with the help of the coordinator? How do I share view models? How do I share view models when I have UIKit code and SwiftUI code? So I'm trying to put a lot of stuff in this. Also, you will see some combine. This is just very convenient because it's already in SwiftUI included. So we're just using the same patterns. I don't want to think too differently when I'm in UIKit and in SwiftUI. Otherwise, I'm getting confused, and I don't like to get confused. It's supposed to be very easy on my mind. We'll try to build a smaller projects covering a lot of these topics. I have a lot more example projects. I built much more extensive with Combine in my Combine course. So if you want to see a lot more examples with using Firebase, different subflow for authentication, and then moving to the main application and where to load data, that might also be interesting. Before we head into the code, I need to talk first about what's the idea, a little bit about the theory of the coordinator pattern. What's the motivation? This is even more important because it's not a design pattern that is very strict. There's a lot of different implementations. I will show the basics, and when I deviate from what I saw mostly, I will explain why I do that, so you can decide what you prefer, if it's also convenient for you, if it makes sense. Starting with a little bit of how this problem evolved that the coordinator pattern is trying to fix. So in UIKit, the recommended pattern is MVVM. So we have a model, controller, and view. The view is basically responsible for the visible part. So we have all the UI views, UI buttons, table views, but also things that they not only display things, they also receive user input. On the very other side, we have the models. So this is our data. And the view controller is basically the middleware that takes the data, that checks when things are changing, and then updates the UI. And the opposite direction, if the UI user input comes through the UI, then the controller needs to know about this, react to it, and change the data. In this case, a lot of the code goes into the view controller, which is why oftentimes it gets super big, and we get the massive view controller problem. In addition to this, you don't only have one view controller, you have multiple view controllers. And the other problem is now that you need to sometimes pass data from one view controller to the other. If your data is a struct, when you pass it, you actually create a copy if you do that with structs. So the second view controller has a copy, the third view controller has another copy. If you change something for this data, maybe the user goes deep into the settings and changes the name. The third view controller has now the updated name of the user. You pop back to the first view controller. Then the first view controller needs to know the data. And because you only changed the copy, not the data that is in the first view controller. So you are getting more updating issues. So the first thing you can do in order to minimize your huge view controllers to add another layer, which is the view model. So now the data lives in the view model, and changes to the data or fetching the data, for example, if you are loading it from the file system, this code would go in the view model. So now the controller doesn't access the data directly from the model, it goes through the view model. 4 different file types. If you now look at this case of having multiple view controllers, we have now the first view controller that has the view model or an instance of the view model. When you push to a next view controller, you're not creating a copy of the data. When you pass this view model, you are passing a reference. Same from the second to the third. When the third view controller changes then the data that lives in the view model and you pop back, all of these 3 view controllers will have the same data because they're accessing the same instance of this view model. Basically what you do is you're taking the view model or the data one step out of the view controllers. I already put this one layer higher, and the question is, okay, should each of these view controller pass the reference to this view model? Because I still need to give it to these view controllers. So maybe we need to have another layer above the view controllers. And the second thing that this layer on top should also do, that would be convenient, is maybe take care of pushing and popping and creating navigation stacks, or the UI tab view controller, customizing, creating view controllers. Because in this example, view controller 2 creates an instance of view controller 3 and pushes it onto the navigation stack. Maybe I change my mind and suddenly I want to have the third view controller shown modally. Then I would need to go into view controller 2 or I need to check where I actually created view controller 3, and I need to navigate it from one view controller to the other, which sometimes it's just nicer to store code where it logically belongs to. I know this is a very difficult thing, and usually I have to think a lot about this, where it's nicely stored so I can find it again and it makes sense. There's things that are similar to this, and in this case we just want to have something that takes care of the coordination between these different view controllers and the navigation stack, and also passes the data to all of these view controllers, or is responsible for sharing the data between different view controllers. And that's why it's very nice to have the coordinator pattern, because this is basically this one layer that I talked about is now the coordinator class. So this is the one that creates UINavigationViewControllers or UI tab view controllers, customizes them and puts view controllers on them, or it pushes or pops different view controllers on the stack. The important thing is also it's owning view model, and it owns the state, certain states. For example, it owns the navigation state, but it can also own something like view models that contain the authentication state of the user. And then, because if the authentication state changes, the coordinator needs to decide which view controller to show. If the user is not logged in, the coordinator might want to show the authentication flow, where you have to create an account or sign in. Once the state changes to a logged in user, the coordinator wants to change the navigation stack or show a different subflow of the main application. Also, in some cases, you have the view controller that gets the data, but for example, this login state, it needs to, or it wants, the user might want to see something differently, or it just has an event happens that the user initializes. The view controller, you press a button, the view controller has this event happened because it has the button, so it knows when it happens, and needs to tell the coordinator, we need to do something, I'm not really sure what, but take actions. So the view controllers need to tell the coordinator something happened, do something. So maybe you press the button and the coordinator needs to push another view controller on top. Or you're pressing a dismiss and the coordinator needs to decide to pop back to the root view controller. And it's important that in this case you don't see any errors between different view controllers, but the communication goes from one view controller to the coordinator. Basically, the view controller, the view becomes very dumb. This sounds negative, but it's actually very positive, because the task of the view controller is the easier it is to understand what it does and to organize your project, because you know, okay, this is the view controller, it's supposed to just show these 3 buttons and 2 text fields. Nothing more, no handling of the data, no server request, is just showing this and then passing the actions that have to be done to the view models or the coordinator. It makes the code much more modular to go through these 4 different instances, because now we have data files, view controller files, views, view models, and the coordinator. Okay, it's getting a lot, and you already see that we have a lot of these arrows, which means we have a lot of, because we modularized our code so much, we now have the problem of, we divided our code base in different files, but to easier organize everything, but we created another problem is I have now much more files that I have to sync to each other. They have to talk to each other. You see all the errors I suddenly have. There was a lot less errors before. Errors. This means we have to be more careful about the communication patterns that we are using. This is the summary of the most important communication patterns. So we have the observer patterns with the classes of the notification center, which is used very heavily. This is simply because everybody can post notifications. Multiple classes can post the same notification, and multiple classes instances can also receive, observe notifications. So it's a many-to-many communication, which is with a very low amount of code you have to do. And you can easily connect very different parts of your application. The problem is it's really difficult sometimes to know what's going on, especially if there's conflicting notifications and you're doing things in a weird order. So it's a bit more, I find it more hard to debug and to understand, because suddenly you need to, there's a notification, but where's this going? Following the flow of data is quite hard with this. Then we have target action pattern, but this is more for UI elements like buttons. Then we have KVO, key value observation. We could use this to do the communication between our view models, which are classes, and our view controllers. But it's not so intuitive, I think, and it's not so heavily used. The most used is the delegate pattern. This is probably because Apple uses it so much for its own APIs, like the UI table view delegates. And it's also the delegate pattern is also the one that is most common, what I saw for the coordinator pattern. This means that if you do this, you have to have a coordinator, you have to have a delegate between each of your view controllers and each of your coordinators. So you have, in this short example, you would have 3 delegate classes that you have to, the protocols you have to define, and then you have to conform. But if you have multiple subflows of child coordinators with different view controllers, you have multiple instances of delegates you have to move upwards in order to propagate certain events or data. And I think it's a little bit hard. I don't like it too much because it always, I'm like, you end up with very long names of second view controllers delegate, and like which one's delegate and which one is doing this. Oh, yeah, no, it's called this one, and no, it's called this one. And it's not very state driven. It doesn't work for SwiftUI so well. It's just harder to work with. Closures are, they can do whatever delegates can do. They're also one-to-one communication. You can have one view controller talk to one coordinator. And I can also make this work with SwiftUI views together with a coordinator, for example. But again, it's like one-to-one, and it's action functional programming. So I would like to progress in my, because I already started on my journey of state-driven navigation, I would like to have my navigation also state-driven with UIKit. So I want to declare one state and then let the coordinator react to changes of the state, for example, if the user is logged in or not, or if the user saw on the onboarding flow or not. So that's why I really like combined data streams, because SwiftUI already works with this. So I can create data streams from my view models at published properties. I can add as many subscribers or observers. If you look at the observer pattern, I can add a lot of observers to the same publisher. So it has the same advantages as a notification center. I can also allow others to publish new values into the data stream. So I can have multiple recipients. It's a one-to-many relationship, and it's a blind communication because I only expose the publisher. I can expose any publisher, so whoever subscribes can only receive new values, but he cannot post new ones. So I can do some access control. It's a blind communication because I just need to know what needs to react to changes of the state. It is type safe because I need to declare what type my publisher publishes. This is very different to the notification center where you can post something of type any. So you directly see in this case if you have the right type in your data streams or in your dependencies. And I can make my data flow linear because I have 2 ways of communication. One path that is depending on the state, that reacts to this state, showing a different view controller. And the other part is, the other flow is events or triggers that can change the state. So I only need to, every time I do something, I only need to think of one. Either I have a button, okay, I just change the state, or I set the flow up and I was like, okay, I only need to take care now of what do I show in which case. So I don't need to have too many things in my mind. You can also see this as a data stream in your code. So we have the model which becomes a publisher, so it has a data stream towards the view models, who are owning the state, and the view controllers or the views can actually subscribe or take the new state or receive always the new state and update the UI. Certain events in the UI, for example, buttons, these events can then go through the controller, and the controller tells the view model that something changed. The view model then changes the data, which is triggering the publisher and updating the UI. So the view controller, or from a target action button inside the view controller, you would never directly change the data. You would go through this loop. It's like this is the unidirectional flow that I was talking about. You don't change data from different places in different ways, in different order. You always go, this is the one source of truth, this is the one data that I want to use. I will create a new project. So it's called file new project. And in this case, I'm going to use because I need to use UIKit for the navigation. I cannot use a multi-platform. That would fix me to SwiftUI. And here, if I choose SwiftUI, then I get the SwiftUI lifecycle, which I really don't want. I want to do everything in UIKit, so I have to go with the storyboard. I have no other option. This is a coordinator project. I don't use coordinator or tests right now, although the tests are quite interesting with the coordinator pattern. From the settings, I can go for iOS 13 because I use UIKit for the navigation. Now, I said we have this storyboard which I want to get rid of very, very much. So I start by deleting this. Then in the coordinator project settings here for the main interface, I am going to remove this entry. And the last thing is I need to, in the info plist, change one line or delete one line, because here in the scene configuration, it says basically it's telling the system to use the main storyboard to launch the application, so I don't want to do this, so I delete this. Okay, these are I just removed everything, but if I run this, I don't see anything. So we need to at least show this one view controller maybe. In order to see that we have this view controller, I'm going to change the background color to cyan. So now in the app delegate, this is where the application launches, and we have to set up everything in the scene delegate, especially if you want to go for the iPad where you have multiple instances of the scene delegate. So I'm just going to clean this up. I'm removing all the implementation except the scene will connect to a session. And here I get the UI scene, and I can put some views on this scene, like my one view controller. So I'm going to start with creating a window scene. So if let window scene is the scene as a UI window scene. If I can do this, and then I can create a window. This is a UI window from a window scene. Now I can configure this window because it has a root view controller property. This is a UI view controller. So I can set anything that is a UI view controller, a UI navigation view controller, also inherits from UI view controller. So I can use here my view controller. Then I need to, because I created this window, I need to keep the window in order to keep everything alive. And I already prepared this with this one window property. So I can assign myself .window to the window that I just configured. And in order to start this window, and to make it visible and start it, we have to call the window.makeKey invisible. Key invisible. So this does two things. It makes it key. So this is the running application, or it's on macOS that would be the active window, and make it visible. Okay, that's it. Now if I run this, I see my application. Okay, I only have here one cyan view controller. So this is one way of using a UI view controller. You can also create a SwiftUI view. So this is a new file, SwiftUI view, content view, the good old content view. And I'm using here one text SwiftUI content view. So now in my scene delegate, I want to use the content view, not the view controller. So I have to change the view controller of my window. Because this is a UI view controller, I need to wrap this in a UI hosting controller, which takes in a root view, which is a SwiftUI view. So I can use my content view. And let's run again. We should see a different launch of the application. And indeed, I see the SwiftUI view that I just created. With these changes, I could now launch my application programmatically from whatever point I wanted. A specific view controller or my SwiftUI view. The next step is to not configure this here in the scene delegate, but to use the one more layer that I talked about, which is the coordinators. Okay, so I'm just going to create a group, which is protocols. And in here, I'm going to create this one protocol, which is the coordinator. So this is a protocol coordinator. And I'm going to use one function, which is start. It doesn't take in any arguments. This is the very basic commonality between all the implementations of the coordinator. Basically, all of your coordinators or sub-coordinators need to conform to this protocol, and they have to have a start function. In the start function, you will start putting your view controllers, starting whatever the view controllers need for fetching their data. So in our example, I wanted to start with the one coordinator that starts the whole application. So the one that I will access from the scene delegate. So I'm creating a new file, This is a Swift file. All of my coordinators are just Swift classes. So this is the application coordinator. So this is a class, application coordinator. This is conforming to coordinator. Okay, now it's complaining that I don't conform to my own protocol. I just use the auto-completion, and this is indeed the one function that I said is the start function. So I wanted to move some of the code from the scene delegate in here, because setting up which view controller comes first should be done by the coordinator, creating these view controllers. I can do some of this in the initializer of this main application coordinator or in the start function. So let's just have a look what the scene delegate did. So all of these configuration of the scene, especially the line where I created my UI controller needs to go there. And we need to set it to the window. So I probably just move the whole window and this part also over. So I'm copying this. And in the init, I say window. This is UI window. I need to keep reference to this. So this is let window UI window. And I'm going to self.window is this window. So in my scene delegate, once I created this window, I should create my coordinator or my application coordinator with this one window. And I also should call the start function. Now the start function is what I do in, for example, here with this setting the root view controller. So I'm going to move this into the start function. And I'm not storing the window here anymore because I do that in my application coordinator, but I need to keep reference to the coordinator because it's a class, otherwise my whole application would just not do anything. So this is my main application coordinator. So then I would assign my application coordinator, I just need to keep reference to this. And in my application coordinator, because I use your UI hosting controller, I need to import SwiftUI. So now if I run this, we should actually see still the same. Yeah. So this is it for setting up the scene delegate. Every time for every new scene, we are creating, we're configuring the window and adding a application coordinator who is responsible for everything. Now we can continue working on the coordinator. One very common thing is to have not just a view controller, but a UI navigation controller, or you would have different subflows. So now I'm going to create two different subflows. One for the onboarding, so I'm creating a new group with onboarding, and then the other one is main. So let's start by just showing the onboarding, and then also switching to the main area once we finish the onboarding. So I need to have a another coordinator, which is my onboarding coordinator. Coordinator. So this is class onboarding coordinator. This is coordinator. And I'm implementing an empty start function for now, because I don't have anything to actually show so far. And in this case, I want to have do quite a lot of onboarding flows have a page view controller. I could not do this in UIKit, but I wanted to have some mix and match a little bit in this project. So in this part, I use a SwiftUI view, and I use the SwiftUI page view controller. So this is a new file, SwiftUI view. This is an onboarding view. I'm going to show 3 images in my page view controller. This is not supposed to be like crazy amazing. So I basically add here 3 images that I downloaded from the internet. So it's like a llama, a cat, and a rose. So in my onboarding view, I can use depending on which level you are. I think I did I put 13? I think I'm just going to use 14, so I don't spend too much time. So this is a tab view, and I need to add here my images. So this is a cat, this is a llama, this is a rose. Okay, I need to actually format them. So this needs to be resizable, and then scale to fit, and then for the, I need to add a tag, so this is tag 0, tag 1, and tag 2. So you don't see the tab bar. I need to change the tab view style, tab to a page, tab view style. Still don't see it, so I need to change the background because it's white to color.black. Edges ignore save area.all. So now you see the tab bar, and I need to copy paste this resizable and scalable. So I'm just going to create a subview, extract subview. I don't know why it doesn't auto complete. Before it allowed me to change the name directly. So this is a scaled image view with the name is a string name. So this is a scaled image view. I can use this for the other two images. And I actually need to take out the tag. So this is working. Probably I should not leave this in here. I'm just going to create another group with helper. We can talk about organization a little bit later once I have more files that I decide what to do. So this was the scaled image view. So I just move this in here because it might be convenient. And I'm not going to use here preview for now to save time. Now if I run this in the preview, I have here this nice 3 images that I can slide, but I need to have some way of leaving the onboarding flow. If I would have made my own UI page view controller, I could have access to the moment when you try to swipe the last one and then dismiss this. But I'm going to make this very easy and add another one for a button and just say done. So now I have these 3 images and the done button. In order to communicate to the onboarding coordinator from this view that we want to be done now, one of the communication patterns that I mentioned is a action call. So done requested. This is a closure that does not take any arguments and doesn't return any. So I can call here done requested. And I need to add this in here. Okay, now we can use this in the onboarding coordinator. So I said that in the start function I want to create this view. This is a onboarding view. And I want to create a view controller with the UI Hastings controller. This is normal for wrapping anything SwiftUI related into our UIKit navigation architecture. So this is my view. So now I have this view controller. I need to store this and put this also on my window scene. So what I can do is, what is very common, is that we have a property in this coordinator, which is the root view controller or any controller. And in my case, I'm just going to create here UI view controller. So this is, when I create one of these coordinators, it's an empty view controller. But once I press on start, I actually want to put something useful on this. So my root view controller gets this hostings controller with the onboarding view. Okay, now I have this one coordinator that actually does something. I can now use this coordinator from my application coordinator. Instead of my content view, I don't want to do this here. When I start, I want to start my child coordinator. So this is my onboarding coordinator. Then I call onboarding coordinator.start. And now I can take the root view controller of this onboarding coordinator and put this on my window. So I can say the Windows root view controller becomes the onboarding coordinator's root view controller. So I'm basically managing one level up. This is getting a little bit more clear if you have another coordinator. When I start this, I do populate my window with this root view controller, but I lose my onboarding coordinator and all the things that I would want to do in there. So this is the other thing we usually do. We have to have here a property child coordinator This is an array of coordinator. That's the one reason why we actually have this protocol implemented, because then I can store this as a type. I can store here multiple ones and different ones. So now I can say self.child coordinators is this one onboarding coordinator. Okay, if you run this, we have everything, we keep everything, we have our view controllers. I can scroll here because my subflow, my onboarding subflow is working. The done is not really doing anything because I didn't react to anything. It's currently only living in my onboarding coordinator here, but nothing is done. And actually, the one who's supposed to do anything is not this onboarding coordinator, is the application coordinator, because I want to switch to another subflow, the main flow. So first I have to actually have to set up something so we can see something. This is a Swift file for another coordinator. So this is my main coordinator as the main flow of my app, because the onboarding is just the start. Coordinator. So starting again with class main coordinator. There's a coordinator. Func start. Okay, what did I want to do in here? Is just to mix it up, do the navigation now with a UI tab view controller with 2 navigation view controllers for each tab. Each tab gets 1 navigation view controller, which is wrapped in another coordinator. So basically I have a first tab and a second tab. I know it's not very creative, so maybe I just start here by creating 2 subviews. This is my first and second. Not going to concentrate very much on that this is doing something useful, more on just trying different options. So my first tab would have, as I said, a coordinator. First tab coordinator. Bloop. So this is class first tab coordinator. As a coordinator, this needs to have a start function, and the root view var root view controller of this subflow is a navigation UI navigation controller. We need to configure what we put on this one, as opposed to my main coordinator, which is where the root view var root view controller is a UI tab view tab bar controller. So I like to name the main access for the subflow root view controller. It's just and then I could directly see, oh, my subflow has a tab view style or a navigation controller, and then I actually need also a second tab coordinator. Okay, it's pretty much the same. Actually, I can also delete this part. Tab coordinator. And okay, now I have these coordinators, but I actually need to put something on top or inside. So I'm going to, for my first tab, have 2 view controllers. I want to have a detail one so I can use the navigation controller to push to the second one. So I need 2 view controllers. These are both CocoaTouch classes. So this is my first controller. Okay, placing it in this folder. In order to continue my mix and match of SwiftUI and UIKit, because then I can also show how to share data between a view controller and a SwiftUI view. I am making the detail of the first one a SwiftUI view. So this is my first detail view without controller. So yeah, SwiftUI view. And then for the second tab, I'm going to create another view controller. Just to go through all the different cases, this is my second tab, my second view controller, and also with a zip file. So we have all different kinds of files here that we want to work with. In order to just test a couple of things, I am going to, similar to actually this view controller, change the colors here to this one. I am going to delete the prepare for Zach because we're not using anything of this kind. That kind of code goes into the coordinator. Then the first detail view control, first detail. So I'm just going to write here first detail, and then the second view controller. This has a system background, and maybe I just add a label. Can just also add more, and then maybe one of my images. This is probably not good. Adding some constraints. Need to make this resizable. I'm just adding some constraints. Okay, this depends, and then I make the text in the center. Basically, I just want to have something on the screen. Okay, now that I have these view controllers, I should actually use them in my coordinators. So starting with the second one, basically just want to make the first view controller on the stack this one. I am creating a lazy var for my view controller. This is the second view controller. And I'm creating this let VC is a second view controller. Then maybe I want to do the title because it's in navigation stack of second. And then I wanted to put this return this. So now in the start function, I actually want to use this property and put it on my, and then close parenthesis. Because it's lazy, it will only be executed once we need it. For example, when I call here start. So the root view controller, I can set because it's a UI navigation controller, you can look at the functions. Set view controller. This is an array of view controllers, but I only have one in this stack, which is my second. And you can decide if it's animated or not. In this case, because it's the first one, I don't want to animate, so this is false. Okay, this is pretty much it for the second tab. My first tab is a bit more complicated. So again, I'm creating here a lazy var. First view controller. This is a first view controller. And I'm creating this let VC is a first view controller. This VC is title first title. And then I'm returning this. You can we'll see more where I add certain stuff. And then again in the start function, I can set my view controllers in the function of saying the view controller that I want to show first is my first controller, animated false. I haven't set up anything for pushing to the detail because I didn't put anything on the first view controller, so we do that a little bit later. So now in my main coordinator, where I have this tab bar controller, I can configure my two tabs and use my two child view controllers, which means I actually also need to have here an array of child coordinator. This is coordinator. So in the start function, so I create my first tab coordinator, I call start, so this is creating the root view controller, and this is creating the view controllers, and then I need to store this. Now I actually need to, I will do the same with the second one. And now I have these two coordinators with these two root view controls. This is actually the thing that I want to have. So my tab bar I can configure. So this is a little bit checking how to set this. You can just Google how to programmatically set the UI tab bar controller. So it has a property view or you read documentation. A UI controller array. So I can give here my first coordinator's root view controller and my second coordinator's root view controller. Okay, I did not actually, in order to see that this is actually working, I need to change my application coordinator because right now I'm here all the time using the onboarding one. Going to uncomment this. Let main coordinator.start. And then Windows root view controller is the main coordinator's root view controller. And then self.child coordinators becomes this one coordinator. So when I launch, I should actually see my tab bar controller. Except you don't really see much because I didn't have here the tab bar. I also need to configure this. So let's go back to the main coordinator. So I have to set this on the view controllers. So my first view controller is my first coordinator's view root view controller. And this first view controller has a type bar item property where I can set the UI type bar item that I want to have. This is UI tab bar item. And I can give here a title image and selected image. So for example, this is first the image with named. This is because I can use system icons. So for example, paper plane. And then the second image is paperplane.fill. So it complains because I didn't use my first view controller, so I'm just going to remove this here when I set this on my tab bar. Okay, let's run this again to see if I have here no one item. There it is. It's not named, it's system named. Sometimes. So now I have here this nice icon. Okay, maybe I need to do the same here for my second. So I'm going to create a little convenience function. So this is a function that takes any UIViewController, the title I want to set, the image name and the selected image name. So I create these images from this SF symbols and then create this UI tab bar item and set it to my view controller. Which means that this line becomes a lot easier. I can just call set up first view controller. Okay, now I deleted everything. So first title, first tab, using this image and his selected name, and I can do the same for the second one. Changing the title to second tab, the image to bell and bell.fill. And then I'm using this view controller to set on my tab. So now I have two of these icons. They look a little bit different because I didn't set a background color for my tab bar. So when do I customize my UI tab bar controller? So we can place this at different positions. I usually had here an initializer. So I can actually set my self.root view controller to a UI tab bar controller. Because sometimes you can only set certain things when you initialize them. Now I have the possibility to say, for example, tab bar dot is translucent is true. Root view controllers tab bar dot background color is light gray. So now you see it a little bit better. But basically you can, because you have access to these view controllers or tab bar controllers, you can change everything, the fonts, font colors, background, translucent, you name it. So I did this in the initializer, and in the start function I just create the view controllers that I need to show. So this is already looking quite good. You can just use this one coordinator for a different flow. For example, here I have a tab bar controller, and inside here I have a UINavigationViewController. Right now my navigation controller's title is this first. Maybe I want to have a large title. So again, I do the same with the initializer. Setting this up. And then root view controller's navigation bar. Again, here you can set up everything. It's translucent, bar style, bar text attributes. So this is the font stuff. Big items, bar tint color, compact appearance. Prefers large title as true. So now I should run and I see the large titles. So now the first title is large. Because I find this coordinator is very convenient to set different subflows up with just the navigation bar, for example, or titles, bar items, or here the styling of the main flow. Now that we set up our basic flow elements, subflows, with multiple child coordinators, which is good for testing, the next thing I want to do is actually be able to switch for different flows and talk about the communication between these different instances. With the first example being here in my application coordinator. Right now I can only switch here. I uncommented the onboarding coordinator in order to see the other one, but I want to do that during runtime, depending on when the user finishes the onboarding coordinator. So I need to make this work together. And the first approach that I'm going to suggest is very much combine. So what I'm going to use is, if you don't like combine, I'm not going to use complicated data streams, I'm using one of the basic publishers. You can also, it's enough if you watched one of my other tutorials where I show the introduction to Combine. And so I have to define a state that will define which flow I show, the onboarding or the main one. And it's depending on if the user has seen the onboarding. And because I need to create a state that I can react to, I need to create a publisher for this. So this is a let has seen onboarding. This is a current value subject because you always have to have a value. The subjects are easy to use with UIKit. So this is a Boolean value and it never fails. So it publishes Booleans and it never has an error. And the initial value that I'm thinking is false. So in the very first time I launch this, is probably the user has never seen the onboarding. The nice thing about this current value subjects is that there are classes or subjects that are classes, so I can pass them to my view controllers. I have now this one state, and we need to do two very different things. First, we need to define what is shown for each state that is possible, for the false and true case for this has seen onboarding. So in my start function, instead of here defining directly which hard code, only showing always one of these coordinators, I'm going to set up a data stream that will react to changes to my has seen onboarding to update UI. So this is has seen onboarding dot, and so this is the way I can subscribe. And I use here a sync, and I get always, every time it changes, I get the value has seen. In order to keep this data stream alive, I need to store it in set of any cancellables. So I need to create a set of any cancellables. So var subscriptions set of any cancellables. Starting off with an empty one, and then I can store this in my subscriptions. Okay, now that I have this has seen onboarding as subscribed, I can say if the user has seen onboarding, I have this true case and else the false case. So in here, I can basically use this two blocks. So the onboarding, I'm moving into the has not seen case, the false case. Just need to format this there. And the main coordinator, I'm showing when the user has seen the onboarding. I am, because of disclosures here, need to work with, I want to prevent reference cycles, memory leaks, so I make this a weak self. So all of these become question marks, self dot question mark, self dot question mark, self dot question mark. So that's it. I did the one part of my data stream, my unidirectional data streams from the state to whatever needs to change depending on change of the state, switching between these two flows. The second part of the state-driven development is changing the state. I need to set this to true, has seen the onboarding. And the one that has to change this is my onboarding flow. So my onboarding coordinator actually needs to have access to this state property. So I need to create a property inside my onboarding coordinator. So this is var has seen onboarding. This is of type current value, importing combine, current value subject of type bool, and it never fails. I need to here get this in the initializer, has seen onboarding, this type, self.has has seen onboarding. So I need to go back here in my application coordinator because now this initializer should change for the onboarding coordinator. And I can pass the has seen onboarding, the subject. I can also make this here a check, has seen onboarding, self.has seen onboarding, and then pass this one. Just to make sure I don't crash my app. Else if let has seen onboarding. I'm passing here this property, the state, access to the state to my onboarding coordinator. So now this coordinator can actually change the state because at the end of the flow, when I press done, I want to change the state. And this is done here in this, with this closure. You could also pass the state further. So in here I can say has seen onboarding.send true. And again I need to use here week self in self dot. So then this is the only one that actually can change it. If you have positions where you only want to react to it but not let it change, you can pass this current value subject here. Where's my main in my application coordinator. Instead of passing here this has seen onboarding as the current value subject, I can make this erase to any publisher, and then it becomes an any publisher, and the onboarding coordinator could not send any more values, so I can do some access control. But in this case, I actually want to do this, and the coordinator, the onboarding coordinator, has only access to this one property, which is good. Okay, let's see if my my little data streams work. Let's go here. I press done, and I go to the main area of my app. So it works very nicely. Onboarding coordinator had access to this one publisher. It was changing it, but it didn't know what was happening afterwards. The one that was deciding about this one property is the application coordinator. That is the one that decides when to switch which subflow. You already know that, okay, on the very high level, I have this main different subflows that my application can go into. Now the next thing that I want to actually change is if I launch the application again, it's going back to the onboarding. I don't really like that. I want to go back to my main flow, which means that the next time I'm launching, I need to actually have saved has the user seen the onboarding, and I do that in the user default. So in addition, when I launch this application coordinator, I need to get the data from somewhere, and I use the user default. So I create this little function for doing all of this. So first, I'm accessing here the user default Boolean value for this key has seen onboarding. And then when I have this new value, I'm actually setting this here to my current value subject or to the newest state. And when I update this, when this becomes doing my first launch, true, I need to save this in the user defaults for next time. So I again use here data stream to subscribe to it. And in this case, I only want to save this actually if it's true. So that's why I use this filter. So I also need to do here my setup. So my start function, I first do the setup onboarding value. If you don't want to go through, for example, another useful filter for not doing too much work is a remove duplicates. Then, for example, if I change from false to false, it will not go further because it already is false. Or you can use throttle or debounce to not immediately react, but only wait a little bit. Okay, now we try again if my saving actually works. Okay, the first time we are still going in this flow, then I press done. I go in the main part of my app, I close my app. Actually, I need to close this properly. If I run this again, I directly see here my main part of the application because it saved it and it fetched it from the user default and it was true, and that's why I didn't. In this data stream, it went into the case of has seen and showed the main application coordinator. So you see, I have here this nice data stream. I know which, because I'm passing it directly to each of my children or my view controllers or my coordinators. Each of them knows exactly, I can directly see here, okay, this onboarding coordinator has access to this property that can change it. The other one doesn't know about it, but it will be shown in this state. So you can just pass down this kind of information. You see how I can pass down state and react to state between different coordinators and switch between different coordinators or subflows. Now that I have this, let's work on the main coordinator and then specifically on the first tab, because I actually want to make this more interesting and push to the detail and also pass some data between them. Because I have here one view controller, UIViewController, and one SwiftUI view. So the data that I wanted to share, just going to create here a view model. This is a Swift file. This is my first view model, first tab view model. I just need to have some data. This is a class. This has to be an observable object for one of my SwiftUI views. For the UIKit view, I don't need this. Then I create here at published var two string properties. One of them I just use this name. Maybe it's the username. It's a string. It's nothing in the beginning. Add published var email. This is another string. And again, it's empty. So I just want to have one view model that and maybe in the SwiftUI view, we are going to use this view model and we are going to actually change the properties. And in the, so in here, I use this, and in the first view controller, I just display this. So we see when to call for updates. Okay, the first detail view. I need to follow SwiftUI rules, and in this case, it has to be an observed object, because this view is not the owner. This view is getting this view model from the coordinator. Var view model. This is a first tab view model. Need to pass this in the preview provider. So just create an empty one. So in here, maybe in addition to this text, so I'm embedding the text in a VStack. So I can add here 2 text fields. One for the name, binding to my view model's name. And then just make this a text field style of rounded border text field style. And the second one for my email, $.viewModel.email. Again, the text field style with rounded border text field style. And maybe I'm adding here padding. Okay, let's just run this. Okay, that looks good enough for me. So this view is going to have access to this data and change it. And my first view controller, I actually only want to, I don't want to make this really hard on myself. I just want to create here a UI label that shows this. This is a info label. And this is a UI label optional. And I'm going to configure this in a setup function. So setup info label. And I need to have here access to the view model. This is the first tab view model. I create a UI label with fixed frame. Obviously you could use the auto layout. It's probably nicer, but I don't want to make this too big and too long. Then I am using the view model to display the name and the email on this label. Then I add this label to my view and I store this label. So in the view did load, I am going to set up my info label, and maybe I'm going to change from cyan to white. So now I have this one label. The other thing that I need is, because I want to push to the detail, I need to actually have a button to go there, or a means. So I create another function to set up my button, detail button. I am creating a UI button with a fixed frame, making it easy on myself. Then I just change a little bit of styling of the tint color, the title color, the title name, so go to detail. And when I am tapping on this button, I want to call this button action here. And then I'm just adding it to my view. So I also need to just go to detail. This view controller is not supposed to do that. I need to pass this action up to my coordinator. So I could have here another property closure show detail requested. This is not, this is a closure that doesn't take any arguments. And I'm just starting by an empty action call. And when I am tapping on this button, I'm going to execute this function or this closure. I can now use this updated version of my first view controller in my first tab coordinator. So when I created here, so one thing I need to take care of is I have a shared data between these two view controllers, and I need to pass it, and I need to create this view model. And because it's shared between the two view controllers are in this coordinator can be the owner of this view model. You can also go one step higher and put the application coordinator as the owner. Then you can share it even wider over your application. So this is a view model. This is a first tab view model. So when I create my first coordinator, first view controller, I can set the view model to the view model that I created in this coordinator, because I need to initialize it somewhere. And I can also set what's going to happen for this closure. And maybe I'm going to create another function here, go to detail. So I can call this, probably need to use again here a week. With all of this handling around, you always have to think carefully of avoiding memory leaks, because otherwise you create view controllers and more and more view controllers and it just builds up and you never dismiss anything, any coordinators. Okay, so I am in the, so now I have this one request and I actually need to push the second view controller. So in this function I can say UIViewController, because it's a UIViewController, I can say push view controller. Maybe I just create second, let detail view controller is a first detail. I need to use a UI hostings controller again. This is a detail, a first detail view. Give me here my view model. And then I can actually push this detail view controller on my stack. Animation true. Yeah, this is definitely I want to have animated. So let's see what we see. I have no button. Okay, I go back to my first view controller. And yes, I mean, I never called the setup button. So let's do that in the view did load. Okay, I have here this button. Okay, my layout is not amazing. I know, you can improve this if you want to. Okay, here this text field that is supposed to show my name and email. It's not showing anything because I start off with empty strings. I go to the detail and write here the name and email. So this is the data that is shared between these view controllers. I go back and it doesn't show. This is because my first view controller, I only called the setup info label once in the view did load. So this is the first time I create this view controller. When I push back here, it's not called again. I'm not updating anything. So this is again a thing of you have access. This view controller has access to this view model, but it needs to continuously update it. So if one way would be to call this in a different position, for example, view did appear. I could also do this. Okay, maybe I'm just going to remove this from the setup info label. So this is just creating this label. And then in the view did appear, we're updating this. So the view did load is called once when the view controller is created. You can have a look at the view controller lifecycle methods. The 10 different things you can do things when something happens with this view controller. The view did appear happens multiple times. For example, when I go back here, this is appearing again. So you see after it did appear. So first it's not there and then it did appear and we're updating this. That's why you saw it jumping in. If you don't want to have this jumping, you can, this was more demonstrating that actually things happen. You can use the view will appear. Now this is updating at a specific, just once, very few times. If you want to use a little bit more combine to make sure this is correctly updated, we can create another substream. So this is the use case for the view controller to get the updates, get the communication properly to the view model. So I need to import combine. I need to have here a subscription set of any cancellables. So we are not doing this one-time update. When I set up my info label, I also set up the data stream, so the view models email or the view models name can change. So this is combined latest. It means if either the email changes or the name, then I want to do something. So I use here the sync. You get the email. It's the order that I actually created this. Email and name. Okay, I need to again do the week self thing. Dot store in subscriptions. So now I can do this part. So myself dot info labels text should change depending on the name and the email. The other thing I actually probably prefer is if it's empty, I don't want to show anything. So if I check first if it's empty, if the name.count in a very basic way is plus the email.count is larger than 0, then I actually typed anything in. And then I'm going to show this label, and else I'm just setting this info labels text to an empty one. Just a little bit of formatting. So I set up this info label once with this data stream automatically update this during the lifetime of my view controller. Okay, now we don't have anything because I start off empty. Okay, this is probably not the nicest. And then I go back and you see it's there. Back, you see it's always updating. So now we have the case of nicely sharing data between these two view controllers. And the way I did this is my coordinator creates this view model, and it also creates this view controller, and each of these view controllers, the view controller and here the SwiftUI view gets this view model. So they have access to the same data and can share it nicely. You also saw that I can propagate data by saying here show detail is requested. You can also use pass-through subject or put this as a property is shown first detail into a view model. There's multiple things you can do. Because instead I did here this updating at this specific point. If you from the first coordinator want to do something depending on your navigation state, you can also, because I know this first coordinator doesn't really know if the detail is shown or not. I mean, it could, but if you only want to do something specifically when navigation state changes, you can use the delegates for this. So this is my first tab coordinator, and this becomes now a UINavigationController delegate. So this delegate pattern, and now this has to be an NS object. This is going to be interesting. Object, then I have to call here super, and I have to use the override keyword. This is just because this delegate, and then I have to set the root rollers delegate to myself. So this delegate callbacks are actually called. For example, NavigationController will show. So here you get the every time one of the stack changes, one view controller is pushed or popped, something is pushed or popped. You can check what the current state is. So if my new view controller is a UI hosting controller for type first detail view. I'm just going to print here something. Detail will be shown. Else, actually, if this is not null, if I can typecast this. Else, if my view controller can be typecasted as a first view controller. So if this is not null, okay, this is getting a. If it's not null, then I know that this is the new view controller that is shown on top of the stack. So this is print first will be shown. When I launch now, you see directly the first will be shown is printed because I am here on my first view controller. Then I go to the detail and you see detail will be shown, and I go back and first will be shown. So if you want to keep track of which view controller is currently shown or on top of the stack, then these delegate methods are quite useful. You could also use for the onboarding flow, instead of the SwiftUI page view controller or tab bar controller, tab bar, you can also use the UI page view controller and then use the UI page bar delegate to decide what happens when you scroll. And then, for example, if you scroll to the last one, you automatically dismiss it, so the user would need to press on done. That would be an additional advantage because you have all the control that you want to. But the nice thing is, if you just start out a new project like I did, maybe you just want to test certain things and you don't want to go to all the most detailed implementations, then just going for the SwiftUI basic implementations, set up the flow is very easy. You can always change from SwiftUI view to a UIViewController if you need more control, more customization. This was a very extended tutorial on coordinators, and I really like it because now I can do all the customization I want to. For example, I can here add one more detail, and then in the next view controller I can just call on the coordinator to pop to the root view controller, and I wouldn't have these weird animations because I'm accessing directly the UINavigationViewController, so I can pop properly back with the animation that I want to and don't have this weird behavior for certain iOS versions. It is more work than directly going for SwiftUI, but especially if you don't like all of the things that happen with SwiftUI, then maybe that's a good option. The other thing is if you need to support iOS 13, this is probably the best setup, because I had a lot of problems with the layout of iOS 13, so it's nice to be able to fall back to UIKit very easily and also use the navigations from UIKit. Okay, I will finish at this point because it's already quite a lot of things information that I was throwing at you. I will put the project on my GitHub. You can find the link to the project in the description box. Don't forget to like and subscribe to my channel. That would help me a lot. Let me know if you actually prefer this approach than, I don't know, storyboards or going for the SwiftUI navigation. But I think it's a very good approach for larger applications. It's also giving you a good approach for testing, which actually I didn't go into, because you can do easily dependency injection, so you can test the view model separately from the view controllers. It has a lot more potential than what I actually showed here in this tutorial. Thank you for watching. Until next time, happy coding.